Hello everyone, this is Professor Robert Solis. Welcome to this video lesson. We're going to be talking about stacks, specifically array-based stacks. So I want you to think about this array vertically, and the 0 index will be at the bottom, then we have the 1 index, 2 index, 3 index, so forth and so on. And what'll happen is the top of the stack right now is at, let's pretend there's a -1 right here. There is no top of the stack right now because there's nothing inside of the stack. And as you can see here, the stack is simply like a bunch of dishes on top of each other. So you and I, we go to Hometown Buffet. There aren't any dishes in the dish well, so the busboy comes in and puts the first dish in, and the second, and the third, and the fourth. So a stack is a LIFO structure, data structure, a last in, first out. So the last one in, if I put a dish here, 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 the last dish in is the first one to be taken out. All right, so let's say I have some numbers over here, and it doesn't have to be placed inside of our stack in any particular order. And notice that our stack is an integer array-based stack. In other words, this stack can only hold integers. We can have a stack that can only hold characters or doubles or whatever it is that we want to put inside of our stack, but it has to be, just like an array, it has to be specific to a certain data type. All right, so if I'm going to place a number into the stack like this, we are said to push the 5 onto the stack. And now our top indicator is over here at index 0. So to push an item onto the stack means you are placing it onto the stack. Let's do that again. So let's say that I want to push the 27 onto the stack. So we push that onto the stack, and now this is our top index, the index number 1. And finally, let's go ahead and push another number, specifically 13, say for example. And so now our top index is number 2. So we can keep on pushing numbers onto the stack for however large the stack is. Obviously, if the stack is a smaller one like this one, then we can't go beyond 3. Okay, now if I want to peek at the stack, to peek at the stack simply means to look at but not affect, or not to remove. So in this case, if I want to peek, I go to the top and say, well, where is my top? Well, that's an index 2. And what is inside of index 2? The number 13. So to peek at the stack at this moment would reveal the number 13. Peek does not see 27 or 5. Peek only sees the top of the stack. Imagine, again, we're at Sir George's and we're looking at a bunch of stacks, and a bunch of dishes rather, and the dish at the very top has a dirty mark on it because it wasn't washed properly. I can only peek at that top dish. I can't peek at the dishes underneath it. All right, so that's what peek does. Now pop actually removes, it looks at and removes that item. So what pop does, it says, okay, well, first of all, where's the top of the stack? Index 2. So it's going to take that 13 and it's going to say, okay, well, popping the stack means I see the 13 and it's going to move that top index all to number 1. So now if I were to say peek, peek would see the 27 because where's the top of the stack? At index 1, and so it's going to see the 27. All right, so let's say that I pop once again the stack. Okay, well, I pop the stack. That is referring to index number 1, so this guy now gets removed. And then the top index is now going to be index 0. And let's say that I want to push the 13. So I push the 13. That gets placed into the stack. Now the top of the stack is at number 1. So you can see this process that we go through involving push, peek, and pop. So push places items onto the stack, and then the top index moves. Peek just says, let's take a look at whatever you're pointing to, top. And then pop actually looks at and removes an item, and then also moves the top index down 1. Okay, so that's graphically an explanation of how stacks work from an array-based perspective. So let's take a look at the code of how we're going to create an integer array stack. So the first thing that I'm going to do is I'm going to create an integer array stack.h file. Now, the .h file means that I'm going to also have to create an implementation file, the .cpp file, but let's just go ahead and create the .h file at first. All right, so for the .h file, first of all, I create the class with the exact same name as whatever the file name is, and I have private and public members. So the first thing I'm going to do is to create an array. And the array, in this case, is going to be 10 in size. And what is it going to hold? Only integers. So this is a stack that can only hold integers. I'm also going to create that top index item that's going to refer to what is the top of the stack. And in this case, remember when we first started, the top wasn't even looking at 0, right? So let's get these numbers out of here. The top was going to be assigned to -1, and then when I place a number into the stack, then top will be 0. And as I move more numbers in, or as I push more numbers into the stack, the top index will move. Okay, so those are my private instance variables. I'm going to create a default constructor so that when the user creates an object of this type, if there's any initialization that needs to take place, we'll take care of that in the constructor. So I want to find out a couple of things. First of all, is the stack empty? Because if it's empty, then I won't be able to pop. And I won't be able to peek because there's nothing in it. So I better check to see if it's empty. I'm also going to create a push function. So the push function says basically you're going to give me an integer. Now notice what I'm doing. You're going to have to give me an integer by reference. So that address of operator right there says give me the original value, and then I'll take that original value and I'll put that onto the stack. This word const right here indicates that I will not be able to manipulate new entry. So by placing that const there, the value that you give to me, it's protected. It is not, I'm sorry, let me say that again. It is not editable. I can only read it. It's not in write mode, so forth. Oh, you can think of it that way. Okay, and then in terms of the pop function, well, pop means to remove. So whatever the item is that I removed from the stack, let me get that value, and then I'm also going to have to remove it. So notice that this thing returns an integer because that's what my stack holds. So if I implemented the pop function, it would say, okay, well, first of all, what is the number that I just popped? It's 5. Okay, and then by the way, let's go ahead and decrement whatever the value of top is. It was 0. 0 minus 1 is -1. Okay, peek, as you'll recall, means that I'm looking at, but I'm not removing the stack. So I'm just taking a peek at what it looks like. And the const over here means that any of the values inside of this peek method, I won't be able to affect. In essence, I'm in read mode. And then finally, I'm going to have a display function. And the display function will just be to display the contents of the stack. So we don't return anything. We're just going to display those contents. Okay, so let me go ahead and take this, and I'm going to split the screen so that you can see what both sides look like. I don't need this over here. And so let's go over here to the top. So what I'm going to do is I'm going to include IOStream. And this is a user-defined class called integer array stack. So I better include that .h file so that I can manipulate the members and utilize the members of this particular class. Okay, so the first thing that I'll do is I'll indicate whatever that class name is, and in this case it's integer array stack. Colon, colon, we call this the scope resolution operator, and then it's going to reveal to me the members that I have access to. So let me just type this in so you can see what I'm talking about. So we type in the class name, integer array stack, colon, colon, and so notice that you get a drop down. So here are all the members that you have access to. Now notice that items and top have a little tiny padlock on them. So that padlock indicates that these members are private. Everything else is public. So let's see, items has the padlock, top has the padlock. Yep, that makes sense because items and top, those are both private members. So I have access to all of these members, and all I had to do is just select which one that I want to manipulate. And in this case, let's deal with the constructor, which is this guy over here. That's why I use the integer array stack. Open and close parentheses, there we go. So when we first create an object, the first thing that we're going to do is we're going to assign top to -1. In other words, top is not pointing to any of the indices of our array, so that's why we set it equal to -1. That's what happens when we call the constructor. Next we have is empty. So the first thing that you'll notice is I'll just simply take the word bool, and so that's it over here. And now I can't type in is empty. I have to type in the name of the class, then the scope resolution operator, then I'll have access to the is empty. And basically I just want this to be copied and pasted over here, so you'll see is empty with the open close parens and the const. So what that const means, to remind you, is that I cannot affect top. Basically I am in read mode. And so what am I going to do? Well, first of all, I'm going to ask, is top less than 0? So this is going to return a true or a false answer, right? That's what this is supposed to return, a Boolean. So is top less than is top less than 0? Well, in this case, yeah, top is -1. So is top less than 0? Yes. Is it empty? Yeah, in this case it is. But what if top were like over here, say, for example, because the number 5 is right here, okay? All right, so top is equal to 0. All right, so is 0, which is what top is right now. See that? Top is the 0 index. Is 0 less than 0? False. So it would return false. Is this thing empty? No, false. There's a value in it, and sure enough, here's the number 5. Okay, so that's how is empty works. Now let's take a look at the push function. So again, notice that however I declare it here in my .h file, I'm pretty much just copying and pasting it and placing it over here. So in other words, what I'm going to do is I'm going to send you by reference an integer. And that const over there means that we're in read mode. We're not able to manipulate this value. Okay, well the first thing that I'm going to do is if I'm going to push, does this stack have room for a new entry? So in other words, if I had this in the stack and this in the stack, do I have room for a new entry? Sure I do. I have one more space over here for a new entry. But let's say, for example, let me just duplicate this, and I don't have to type in another number, but I'll just put 7 over here. Okay, so now top is over here. Uh-oh, I am no longer able to put in a new member because, as you can see, my array size is 4, and so there's nothing for me to push into. So that's the question that I'm asking here. Is top less than whatever the max is minus 1? Well, you'll notice over here the maximum stack size that I have is 10. So 10 minus 1 is 9. Top has to be less than 9 in order for me to put something in here into the stack. So this is a little mechanism here that we create, making sure, hey, you can only put something in to the stack if there's room in the stack. Now if there is, well then we increase the value of top, so that index would go from 0 to 1 to 2 to 3, so forth and so on. And then we're going to take that item that you gave to me and we're going to put it into the array, specifically wherever top is. So for example, let's see if I can get a running example here. Let's say right now the top is 2. Okay, so is 2 less than or equal to max stack minus 1? Yes, it is. In other words, I have room in my stack to place another item. Okay, so then what we'll do is we'll increment top. So now top goes from 2 to 3. And then we take that item and we place it into the items array specifically at top. All right, so we take the item and we put it into the array specifically at top. So that's what it looks like graphically, what we're doing over here. All right, so that's what the push method looks like. Let's take a look at pop. Now remember, pop means to remove from. And we're also going to take a look at it. That's why we have that integer right there. So notice over here, I'm just simply copying and pasting over here, and I put the name of the class with the scope resolution operator. All right, so I have over here popped item. I initialize it to 0, but I don't think I have to do that. I'm just trying to say, hey, there's popped item. I don't know what it is, so I'll just set it to 0 because I'm about to change whatever that value is. Well, first of all, if the stack is not empty, for example, let's say for our point of discussion here that the stack is empty, and so that means that top would look like this. If the stack is empty, top basically is pointing to an index number of -1. So notice over here I'm asking, as long as this thing is not empty, you could do the following. See the not operator right here, right? Well, what does is empty do? We just passed that up. What does is empty do? Okay, so is empty says, hey, is the top less than -1? Because if it is, then you're empty. So I can't pop a negative stack. So that's what I'm checking for right here. Is there something in the stack? As long as this is not empty, yeah, there must be something in the stack because it's not empty. It's not is empty. All right, so what does that mean? That means that we're going to get whatever the item is that we're currently pointing to, whatever top is pointing to, and we're going to put that into popped item. So in other words, let's say for example that I have something like this. Right, I got the number 5 here. So if I implement a pop, pop says, okay, so remove that, and I want to know what you are. Okay, you're a 5, and then I'm going to have to decrement that value. So that's what's happening over here. So I want to know what you are, and then by the way, that top index, minus minus. I'm going to decrement it. So we moved it from here to here. So now it's pointing at -1, or it's got the value of -1. And then whatever that item is that I removed, which in this case, in our example, was the number 5, yeah, I'm going to give that to you. I'm going to give you the number that I just popped. Now, we can pop something if the stack is not empty. But if the stack is empty, then I'm just simply going to send out a statement, stack is empty, cannot pop. And so then I return a -1. So in other words, if this thing is returning a -1, then we can just simply say that I wasn't able to return anything. The -1 refers to an error that occurred, say for example. Okay, and then the next method that we're going to take a look at is peek. Now remember, peek is going to simply look at the value at the top of the stack, but it's not going to remove the item. So you'll notice over here that I have this verbiage over here for assert. We don't typically use assert in products that we release to the market. This is good for troubleshooting. And so what it does is it says, okay, we are going to assert that this is not empty. Because if this is not empty, then we can move forward by returning whatever the peek is. If there's nothing to look at, if I have an empty stack, then that could generate an error, right? How do I peek an empty stack? So what the assert does is it's used for troubleshooting so that we can say, yeah, I know that the stack could possibly be empty, but we're going to enforce this precondition and just simply move forward. And again, it's used for debugging purposes. You would never do this on a product that you're going to release to the market. All right, so what peek normally does is if the stack has items, then you simply return what that item is. And notice that we are not manipulating the stack in any way. We're just simply returning whatever top is referring to, or whatever the value of top is in terms of its index. All right, and then finally we have this last method called display. So the purpose of display is to display the contents of the stack. So in this case, if I had, say for example, 5, 13, I'll deliberately mix it up here, 27 and 27. Okay, so we would want to see what the contents of the stack are, which in this case are going to be 5, 13, 7, and 27. But remember, top is pointing to this guy right here at this moment. Okay, so what are we going to do? Okay, so if top is equal to 0, that means that we only have, sorry, I didn't want to do that here. So if top is equal to 0, then we're going to display the cout statement, no elements to display. All right. Now, if we do have items to display, then we're going to go ahead and display them via this for statement. So notice that I create a counter I, and I set I to 0, and as long as I is less than or equal to top, whatever that happens to be, and then I++ to make sure that we propagate through our for loop. So notice that what we're doing, we're saying, okay, what is the content of 0? What is the content of 1? What is the content of 2? What is the content of 3? As long as the counter is less than or equal to top. Okay, so 3 is less than or equal to top, so we wouldn't want to go to 4. So that's what this for loop does. It stops as long as it stops at the point that I is no longer less than or equal to top. And what are we going to do? Simply display the contents of the array. So this will be items 0, items 1, items 2, items 3. Item 0, 1, 2, 3. We'll display the 5, 13, 7, 27 via this for statement, and then we're simply going to go to the beginning of the next line. Okay, so let me think about this here. I'm just thinking about something over here. Look at this. It says if the top is equal to 0. Well, I don't know if that's right, because if the top is equal to 0, that means that this is looking over here at this, and that means that we have an item at 0. So there should be an item there. I think this is supposed to be if top is less than 0. I'm going to have to test this. Maybe my thinking is wrong, but I don't think so. If the top is less than 0, then there are no elements to display because top is -1 maybe. But if this is 0, then yeah, that should have content. So let's remember this. I'm going to save this. Let's remember this. We may have to come back to this and fix it. Okay, so once I have my integer array stack header file and implementation, the CPP file, fixed and ready to go, now I can go ahead and create my main program, which I'm going to call source.cpp, and utilize this. So the first thing that you'll notice that I do is I bring in the header file. So I bring in the integer array stack because I intend on creating an object, and here it is. Here's the object. Now, I'm not going to create an object of, I'm going to create a pointer object of. So that's why we see over here integer array stack. That's a pointer, and so I'm going to call it stack PTR to let me know that this is a pointer. What is this going to be? This is going to be an instantiated object of type integer array stack. Now, because I created stack pointer over here and I have that new keyword over here, that means I'm occupying memory. So what I did at the very beginning of my program is I go down here and I create delete stack pointer, we assign that null pointer. So what this does, this is memory management. This will free up the memory of my stack pointer back to the Windows operating system so that those resources can be used for some other program. So my tendency in programming is whenever I create a new object of a particular class, then what I'll do is I'll just simply also immediately type in the delete statements. That way I don't have to remember, oh, did I perform my memory management? Did I free up the resources here that that this one item is taking in terms of memory from the operating system? So I just type these in pretty much after I type in anything that says new. Okay, now I'm going to ask the user via some, let me actually just get rid of this and put it over here like that, and then we'll just take a look at source by itself. I want to create a type of text-based or console-based menu system that allows the user to enter what they want to do. Do you want to push an item to the stack? Do you want to pop an item from the stack? Do you want to take a look at an item from the stack, that is to peek, or do you want to display the entire stack? So you enter your choice, 1, 2, 3, 4, and then I'll do what you want to do. That's why I have, within a while statement, the try again variable. Whether the user enters y or lowercase y, then we want to display this information. Now this is only going to work on a Windows operating system because Windows has the system function that allows me to affect it, such as clearing the screen or press any key to continue. You can do a web search for all these system commands for Windows. So this program is only going to work on a Windows operating system. It won't work on anything else because only Windows has this idea of accessing system functions. Okay, so what I'm going to do is display this menu and ask the user, what do you want to do? 1, 2, 3, or 4. Once I grab that choice, then I have a switch statement that says, well, if it's 1, if the case is 1, do this. Do this if it's 2. Do this if it's 3. Do this if it's 4. Okay, well, the first item is to push. So number 1, I'm going to push something onto the stack. So I better ask the user, what do you want to push? What integer item do you want to push? The user will enter a number, and then notice how I access the push member. So let me just type it over here. Stack pointer, which is the object that we just created up here. Let me go back over here. Where is it? There it is. I just created a stack pointer. And so to access the members of a stack pointer, I enter the hyphen and then the, what is that? The greater than symbol. And then I have access to all the members. By the way, do you notice that I do not have access to the private members? It's only giving me access to the public members. That's the beauty of information hiding. I don't want you to see the private members because if you touch them, if you affect them, that could have negative consequences. So I only give you access to the public members so that I'm protecting the private data. Well, what do I want to do? Well, in this case, I want to put an item onto the stack, so that means I want to push. And so here it's telling me this is what the push looks like. You've got to give me a value. And by the way, the value that you're going to give to me, you're going to be sending it to me by reference. So I tap over here, push, open parens, and then I send whatever it is that I'm going to send to you. Well, in this case, notice that I have item. Let me delete this over here. I've just obtained from the user the item that is to be pushed, so I put that over here. We push that onto the stack. And then I type in break so that we go to the end and jump out of the switch statement. Now, if the user, let me split the screen here so I don't have to keep on going back and forth. If the user entered the number 2, then that means that we are going to pop. Well, I have a method inside of my stack pointer, so one of those methods or one of those members is pop. And that simply means to remove the item and to move the pointer, or I'm sorry, actually it just simply means to remove the item and then display it to you. So let me go back over here just to remind you, and to remind me too. Pop, what do you do, Pop? Well, first of all, I'm going to get the item at the top of the stack. I'm going to decrement top, and then I'm going to return whatever that popped item is. So this thing is returning an integer. All right, so what this thing does is it returns an integer, namely the integer that was popped. Integer item popped, and then whatever that number is. All right, number 3 is peek, which simply means take a look at the value. So if I access peek, what do? Peek, let's see, where are you? Well, first of all, what I'm going to do is I'm just simply going to return to you whatever the top item is in my integer array. So I'm going to return an integer to you, and so sure enough, the peeked value is whatever that is at the top of the stack. And then finally, number 4 is going to display the contents. So I just simply say contents of the stack, and I have a method that's going to take care of that, namely the display method or function. So if I go over here, the display function is simply going to be returning all the items, or not returning, displaying all the items that are inside of the stack. And then I have a default break if nothing else. Hey, do I want to try this again? Do I want to do something else like pop or peek or push or display? So we ask the user, and then finally we go back to the top of the while statement and say, hey, if try again is yes, then let's do this again. But if not, then we're finished with the program. Okay, so let's see how this works on it. Specifically, I want to remember this. We did a little modification over here for, I think it was display. I think that's right. I changed this from top equals 0, so no elements to display. I don't think that's correct. If the top is less than 0, then there are no elements to display. But let's see what happens here. All right, so let me go ahead and run the program. Would you like to build it? Yes. And it should display this console-based menu structure. Here it is. Okay, so first of all, I want to push an item onto the stack. What is the item I want to push? Yeah, let's push the number 10. Do I want to try again? Yes. So press enter. Okay, now let me go back over here temporarily. Now over here, I think I affected display by doing this. So we should be able to display an item. Let's go back to our menu, and so I'll just simply type in the number 4 and the contents of the stack 10. Perfect. Okay, so what I just typed over here is in fact correct. Do I want to try again? Yes, I do. I want to push another item onto the stack. Let's say 20. All right, try again? Sure. I want to push another item onto the stack. Let's say 30. Do I try again? Yes. Let's go ahead and display the contents of the stack. And sure enough, 10, 20, 30. That's what I entered. Do you want to display again? Yes. Let's peek at the top of the stack. So the top of the stack is the 30. Remember, I entered 10, 20, 30. So the 30 is at the top of the stack. Yeah, let me go ahead and try again. Let's pop from the stack. So that means that get the top item from the stack and remove it. So that's the 30. So now if I display, notice that I just have the 10 and the 20. Perfect, because I popped the 30. Now let's go ahead and pop the 20. So yes, I'm going to number 2, pop. That sounded funny. I'm going to number 2. What I meant to say was I'm going to press option number 2, and I'm going to pop from the stack. And so the integer item that was popped is the number 20. Do I want to try again? Sure. Just specifically, I want to display contents of the stack. Yep, just the number 10. Try again? Sure. And once again, we're going to pop to get rid of that 10. There it is. Display again. Yeah. How about if I press the number 4 here? Contents of the stack. Yeah, no elements to display. That makes sense because our stack is empty. We popped everything. We removed everything out. Let's see. Do I want to try again? No, I don't want to try again. So we're all done. All right. So that is how you create a stack data structure, in this case using integers. Right? That's what we did. We used using an integer array. we're using arrays to create this stack. Now there's another way that we can create a stack using a linked list, and so that's another lesson that I have available for you. In this case, we're creating one with an array. Some of you may think, well, which one should I use? Well, that's kind of a case-by-case question. If you have something that's relatively small, I don't know what that means. Certainly it means 10, certainly it means 100, 1,000 maybe. So forth items. If your array is getting too big, then maybe you should create something like a linked list type of stack, which can shrink or grow. The disadvantage and advantage of creating an array-based stack. The advantage, this thing is quick. You can access information really quick. But you kind of have to know what the size is because it can't grow. Once you've established this array, that's it, it's fixed. So if I'm going to be including a stack to deal with the baseball team, well, what does a baseball team have? I don't know, 17, maybe 20 players in it, a professional baseball team. Well, then using an integer array-based stack would be perfect. But what if I'm talking about the registration for a community college? Well, I don't know what that number is going to be. Is that going to be 11,000 this year, 12,000 next year? We go through a recession, 9,000 the following year. So maybe I should create a linked list-based stack or a link-based stack. So that's the way that you would think about how you would create a particular stack, whether it's using an array or using a linked list. We'll go through more of that in the future lessons. Okay, and that is it. So this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.